Hi, Marcel.
I'm Christoph, as you figured out. Hello.
I'm Tom.
So my name is Michael Clifford.
So my name is Oindrilla Chatterjee.
Hi, Marcel.
Yes, hi, my name is Marcel Hild.
Operate first. In action. Welcome to the show. Now that we know your names, why don't you tell us what you do?
I work at Red Hat at the Emerging Technologies group in the office of the CTO.
Hello. I'm an engineering manager within the Emerging Technologies group of Red Hat.
And I work as a senior data scientist in the Emerging Tech group at Red Hat.
Currently a manager in the Emerging Technologies group.
I work at Red Hat as a principal software engineer in Emerging Technologies group of the office of the CTO.
Operate first sounds a lot like upstream first.
Operate first is, I would say, it's the evolution of our basic tenet at Red Hat called upstream first, where we want to make sure that every line of code that we write also makes it into the upstream community. Why are we doing that? Because this is a way that we enable the communities, which is also our customers, to have a say into the direction of the product and the project that we're engaged in. So it's about leveraging the community as a hive mind, as a collective resource to decide in the direction and to make also make the project and the code quality better, because it gets you peer review, etc. And now these days it's about scale. It's about running a piece of software. So operations and stability and availability has become equally important, if not more important, than the actual product and code features. That's what I call the age of cloud. So how do we envision the tenets, the principles of open source now in that age of cloud, where scalability and all that stuff has become so important? And that's operate first. So hopefully operate first becomes similar as upstream first, a basic tenet for Red Hat and for the open source communities.
Sounds great. Let's get real.
And we also practice operate first in-house at Red Hat. So it's not just the community bits and pieces, but this shifting left mindset, using the software and operating it yourself and building operability right into the software at its core, is being practiced at Red Hat by all the OpenShift offerings that we have, all the managed services offerings that we have, where we use our products and offer them as a service. And in order to do so, obviously, we need to engage engineering teams way earlier in the cycle. That's this shift left mentality, and have them build SLIs, SLOs right into the product itself, so that the operations team can easily operate the service and deliver the 5 nines that everybody is so happy to expect these days.
How did it all start?
Yes, so we started out with a very small setup at the Boston University, hosted in the Mass Open Cloud MOC. That's in Boston, which was a bare metal cluster in their data center, and we basically installed OpenShift on top of that cluster. And then we figured, okay, if we want to set up a real hybrid cloud environment, we need more clusters, obviously. So we have the infrastructure cluster and a workload cluster. And we also moved into the cloud. So we have resources running at the cloud hyperscalers in the cloud. And we also span multiple geos. So we already have a data center in Germany, and we're in the process of setting up more on-premise resources at various sites. We have about 250 external and internal contributors to the community measured in GitHub handles. And we are on a good growth trajectory. The numbers are going to the top right corner, which is what everybody loves. And in terms of diversity, I think we're also a pretty good setup. So we have a lot of young people contributing to it, from students from Boston University and other universities, to interns and co-ops and apprentices, to distinguished engineers at Red Hat contributing to maintaining and developing that cloud setup. In terms of personas, we have people that operate the cloud. We have people that use the cloud as end users, like these data scientists that use the Open Data Hub that's being deployed there, but also architects, solution architects that use that environment for setting up demos for customers so that the customer can really interface and interact with the demo also after the call. So it's not going away. And if you want to be part of this community, you just go to operate-first.cloud, use your GitHub handle, and sign up for accessing those resources. Or you clone the repositories, make changes, and directly contribute back, because all the issues are open, all the data is there, and it's open for contribution. Does a data scientist differ from a developer, or are they basically the same in nature? Or do they have different needs?
It heavily depends on whom you're asking. I'm a developer, so I would say no, they are not very different. They face the same challenges as software developers do, right? A data scientist working in the notebook is always required to install some dependencies. They are going to use modules, PyTorch, natural language toolkit, all these fancy things they're going to use for creating their models or getting the job done. From my perspective as a developer, that is the same problem as a software developer. Making the choice about the right dependency is important. From their point of view, they are obviously very different from software developers. Data scientists work with data. They work in a Jupyter notebook most often. They're going to use Python, yes, that's a common tool. But they are very different. They don't care about dependencies. They just want to include something and get their job done. So they have a little bit different attitude, both groups, to the same problem. They need to manage their software stack. They need to manage their data. They need to create a piece of software that has no bugs. So they are challenging, they are heading the same direction. Their challenge is to create a piece of software.
And often the environment that you have built over working on the project is not really shareable. When you're actually trying to share your code or your repository with somebody else, they are not really able to replicate it or reproduce it. So I think one of the major challenges as a data scientist is to actually provide working, reproducible environment, and to be able to share that and to be able to reproduce workflows.
Okay, so maybe you talk a little bit about this Meteor project that ought to make the life of a data scientist easier and get a little bit more used to the benefits that software developers are usually benefiting from, I guess.
You mean Meteor? The name itself comes from us trying to show some impact on or even better, letting the data scientists show their impact with their analysis with a single click of a button. What we found out is that people, if they are continuously working on something, they don't usually want that. They want an immersive experience where they can change things around, where they can save the progress, where they can amend the work and continue and like maybe stop the workspace and come back to it in 2 weeks and continue working from where they left off, or they would just going back to the Meteor stuff. They would just like to bring their current analysis into the environment, and they care only about the onboarding process, which can be very hard.
So starting Meteor was basically motivated by the idea that we have all that super complicated software engineering tooling, and we want to provide it in a very easy way to the data scientists community, right? So when we are talking about repeatable experiments in the data science domain, we are talking about the problem that we need to have a software stack that is recreatable, reproducible. If you want to run the same experiment in 6 months, we want to base our experiment on the same data, on the same software tools, on the same software stack versions being used. Keeping all that stuff together is most often, again, from our software engineering point of view, a matter of having a Git repository, a notebook, all the libraries, all the dependencies declared and under software version control.
Bring Your Notebook is trying to simplify the process by allowing you to import images, already complete images, prepared images, into your Open Data Hub deployment, into Jupyter Hub. And also, in the next phase, Bring Your Notebook will allow you to update your images and basically store your changes into those images in a certain way.
Turning that into something that is easily usable in the data science domain is the core of Project Meteor. We want to take that repository, turn it into a nice and easy to consume thing on the Open Data Hub project. If you give us your URL of the repository, we're going to turn it into a read-only version, a Jupyter book, so-called, that you can have a look at and present to your colleagues. Or we're going to turn it into a full-blown deployment of that repository on Open Data Hub so that the data scientist, the future data scientist in 6 months, repeating the experiment, is dropped into an environment as it is right here, right now, at the point of time we have frozen the whole experiment in the Git repository. So that's basically what we did with Meteor.
Okay, that sounds like you're solving a lot of problems for data scientists and software engineers and how they worked together.
Shareability, reproducibility, and dependency management are some major challenges in a data scientist's workflow.
To be able to easily, quickly spin up an environment where all my required base packages, all my required dependencies for my modeling efforts are present and always in check, or let's say always available to my collaborators. I think that's a major challenge. It could happen that today everything is working on my local machine. I have a set of dependencies, I have a base environment, and tomorrow I'm working on some other project and everything is broken. And I don't know how to go back to the first one. Or I'm installing a set of packages which do not really work with each other. So these could be some challenges which really hinder the workflow of a data scientist.
Bring Your Own Notebook solves that reproducibility crisis and helps data scientists create and share their project environments.
So it basically provides a platform for the users of Open Data Hub to easily import their working environments, their projects, and be able to spawn it up as a simple Jupyter Hub image and share it with others, just using a URL to their image, let's say. So it's basically right. It's just bringing your own environment, bringing your own notebook environment, and making it into a package format which can be shared with others in a reproducible fashion.
I have a data science project. How do I begin using BYON workflows?
So you have a GitHub project and you have it on a repository, and you have a set of dependencies which enable running that project using some of the set of tools which are available as a part of Thought. You can easily package all those dependencies into a container image, and that's the point where Bring Your Own Notebook comes into picture. You can take that container image, which you have available as a part of a Quay registry, and simply upload it on this admin or this data scientist environment. So there's a simple UI where you can add your image and let the Bring Your Own Notebook pipelines do the work behind the scenes. So at the end of that pipeline, what you get is a custom notebook image made out of your notebook dependencies, your project, your GitHub repository, and it's available as a part of a typical Jupyter Hub spawner page that you're used to seeing.
An upstream project and a community cloud to a Red Hat product feature, the Bring Your Own Notebook effort is a good example of how we are taking the operate first and upstream first approach to building products and services at Red Hat.
So this is a very interesting collaboration that we have been working on. So this is a working group where members from an upstream project, Open Data Hub, the product Roads, and the Operate First community are all involved, and they discuss what's the approach that we want to take to build this in an open environment and bring those learnings back into the product. So what that means is you are developing this on an open cloud environment, the Operate First cloud, and you are making this available for the community to see, use, provide feedback on, and the learnings from that service can be put back into a product. What that means is you take that service and now work with product managers, you work with security people to actually incorporate that feature into the product offering of Red Hat. So it's that full life cycle, starting from an upstream community to an open source upstream project to the Red Hat product offering that we are trying to achieve with this working group.
Look. Self-driving RC cars. AI at the edge.
Yes, so we wanted to work with kind of across the emerging technology groups to put together a demo that would show kind of everyone's capabilities in a single pipeline. And kind of our target that we decided to work with was a toy RC car. This was chosen for a couple of reasons. Like one, I think to have some fun because it's kind of cool to work with self-driving RC cars. But secondly, it kind of serves as a proxy to both like an automotive space, albeit like in a toy example, obviously, but also like very literally in the edge space because the toy cars themselves are like edge devices. So we're targeting two like hardware platforms, a Raspberry Pi and also a NVIDIA Javier. So these are two like unarguably edge devices that we're deploying some machine learning workloads to. We are leveraging an open source project for self-driving RC cars that already has like a pretty robust code base and community. It's called the donkey car. So they have, like I said, it's a Python-based library for driving these cars, as well as training self-driving agents that can go on the car. So we thought this would be like a good target for us. One, there's a lot of existing code for us to use, and hopefully we can also like contribute back to the community with this project. So that's one thing to note. And what the donkey car community provides is obviously instructions for how to assemble a car, which primarily is just your standard RC car with a room for a Raspberry Pi or a Jetson Nano. So those are the two like supported hardware devices for it. And it can be purchased on Amazon for a nominal fee. If you don't have the cash to put forward for an actual physical car, they also provide a simulator that you can run on anywhere, on your laptop or in the cloud, and you can use that to simulate the physical car and drive it, collect data, and also use it to train a model. So you have kind of the digital twin, as we call it, the simulator, or the physical car that you can use as your target. And in our demo, we actually have a build pipeline that after we train our model, it deploys 2 images to Quay, one that targets the actual physical hardware platform, and one that targets the digital twin. This is due to the fact that they have slightly different requirements.
But how do you teach a car to drive?
Great question. So just for sake of simplicity, let's assume we have the digital simulator up and running. We've taken our controller and driven through the track a few times and collected some simulated data. We can then take this data into a Jupyter Hub environment. You can kind of import the images that you collected from your simulator and start to train a model. As of today, there is a image called Octo Keynote that can be used that already has all these things pre-installed for you. So if you use that image, you can go to a notebook that we've developed, and it walks you through the steps of how to train the model. The donkey car project itself already comes with some like simple predefined model architectures. So it's really easy to just kind of click type train, and you can select a couple of different hyperparameters or kind of options that are of interest to you. But then that will go ahead and train the model for you.
How do you deploy your trained model?
Yes, to me, it's some magic. Thankfully, it's very easy for us. I'm sure the people that implemented it worked very hard to make it seem like magic. But essentially, we have once the model is trained, it creates a model file that lives in our notebook or in our Jupyter Lab environment. And once we want to deploy it, all we need to do is commit it and push a tag to our GitHub, we have to commit it to our GitHub repository. So we add the model to GitHub and as a model file, and then we create a tag release and push it. We can do this either from command line within the Jupyter Hub environment, or we can do it from GitHub directly, just clicking on like new tag release. And that will kick off a Tecton pipeline, which has been set up by the Thoth team. And essentially what that does is it looks at the Docker files inside of the repository and builds images according to the specifications in the Docker file. And we have one Docker file that builds an image for the physical car and one that builds an image for the simulated car. It then takes those images, builds them, and pushes them to Quay, where they live for most of the time. And then we use Argo CD, I believe, to actually make sure that the images in the car environment and the simulator environment are matched and up to date with whatever is in Quay. So by simply making a tag release, both of our live deployments are updated with the latest model.
Wow, that was a lot of action, but what is Operate First again?
Kubernetes, OpenShift, Tecton pipelines, Open Data Hub, Jupyter Hub, Operator Framework. What else? I don't know.
You don't use Linux?
Of course.
Linux are containers, I think, right?
Yes, so Operate First Cloud, it's a real platform. It's not fairy tale, it's not fiction. It's a real platform available for you to use, for data scientists to use, and really onboard their projects anytime.
So Operate First is really a philosophy around bringing like operations into the open source world.
And that's this feedback loop from operating something in the community and feeding directly back into the upstream project.
It is very, very direct feedback. And that is what is good from my point of view. It is giving us real world experience rather than unit test driven experience.
You get infrastructure for free, and that's always good.
Like S3 storage, like database engine, Trino, visualization tools, Superset, Seldon operator for model serving, and OpenShift namespace to train models, and so on and so forth.
So it's a wonderful environment for us to really bring everything together. There's no hidden secrets in there. That's pretty much awesome.
A community at its core is the collection and the sum of all the individuals that come to that community. So if you're coming to the Operate First community and you have an idea that fits the mindset of that community, you're welcome.
Very interested in looking at that real world operational data coming out of the Operate First Cloud.
It feels like a paradigm shift, or translating what we had with open source into that cloud age and breaking up the barriers again.
I think the best advice here is always try things out. Always don't be afraid to click those buttons, to really experiment and try things. If it breaks, we did it wrong, and it's not your fault.
So the operations and everything that goes on in behind the scenes on the Operate First Cloud is open for everybody to see.
I think, I don't know, you would need to have my back in here. So yeah, I don't know. Try things out. That's the try things out. That's the recommendation. Call to action.
Now it's time for your part of the action. You can repeat the journey and try the tools yourself at https:/operate-first.cloud/action.